In this video, we'll have a look at some more specialized plotting in Matlab. So far, we've worked with the basic command plot, and of course, with that one, you can do a whole range of things. But sometimes you need some very specific type of plot, and for that, you can use built-in plotting functions in Matlab that are intended for those exactly specific types of plots. So I have a list in here just to give you an example of what those specialized plots could be. But normally, when you know what you would like to plot, you can of course search in help, because there are many more than those ones in here. For instance, the semi-log plotting functions, they are used when your data is such that the scales are so different on x and y axis that rescaling one of the axes into logarithmic scale can help you read the plot better. Then the error bar, for instance, is when you have some series of data, but for every data point you also have some error range. So for instance, then a specific error bar plot would have points of this type. So then you have that given point, but then some range of error known for your measurements. Bar plots are pretty universal to make any plots looking like that, so that you, for instance, represent the count of something in bars, so like histogram style. Bar H, same thing, but with horizontal orientation, so that basically means that our bars would look like that. And then there is stairs, which means that for a specific set of data, it would be drawing stepwise function like that. Stem, so if you have data points, they will be represented by circles, but having also the stem connecting those circles to the, for sure by default to the 0 line, but probably that's also a property you can change when you plot. Then we have pi, so this is for representing, for instance, some portions of data in percentage form or in count form. Then hist is an old function specifically for drawing histograms, and I will actually focus on histogram in this presentation, but not using hist function, but the one named histogram. Hist was popular in older Matlab versions, and now this histogram has actually much more user-friendly functionality that this one is much more recommended. So there's a whole range of plots, and whenever you know how you'd like to represent your data, your results, then you just go for that. Or you can always use the basic plot command and design the plot yourself. So let's go into histogram. The first step, whenever you try to learn how to use a specific function or command in Matlab, then we go to help. And I have already found my histogram in here. So in help, you will always find this section called syntax, and this one basically shows you how to call specific function. Now you'll see quite often a whole list of those options, and the reason is that most of Matlab functions, they have those additional properties that you can change, and in that case, sometimes you may just want to stick to the defaults, and that's where you would just call your function with the specific, with the input, or it gives you an option to add on the properties to be changed, kind of as a varying set of arguments. So in here, histogram, the most basic way to call it is just histogram x. So now x is that series of data that you want to be represented in the histogram plot. Then we can have x comma bins and bins. So now this will point out how many bins you want to see. When you don't say how many, there is some kind of default, and it's most likely calculated based on the amount of your data. In the old hist function, that default was always 10, but in this histogram function in newer Matlab versions, it basically looks how much data you have, and then it adjusts the number of bins for the graph to look optimally nice, let's say. You can also define where are the edges of your bins. So once again, if you don't do it, there will be some default looking histogram, but if you want to predefine the edges, then this option gives you that possibility. And yeah, so let's move on to actual examples. For the purpose, I will actually generate some random numbers. I don't have a ready data set for this, but we can, for instance, generate normally distributed random numbers. They are relatively nice to know how the histogram should look. So I would just say that x is the function for generating normally distributed random numbers in Matlab is rand n. So if you remember, rand was for uniformly distributed numbers and rand n is now for normal. And if you don't change or rescale anything with that rand, then it means it actually generates random numbers with mean value 0 and standard deviation 1. If you want to change that, you may want to, for instance, I want to change the standard deviation to 2. So I have to multiply my numbers, and then I want to also change the mean value to, let's say, 5. So I have to add 5 to that. Now, if I call it just like that, I'll get one number. If I want many, and of course, since I'm trying to do a histogram of something, histogram of one number, it doesn't really make sense. So let's generate, let's say, 10,000 points. Okay, so I'll make a figure, and first let's plot. So now we should have just basically a line which kind of varies in that range where, so the mean value I set to 5, and indeed it roughly looks like it's there. We could as well draw a flat line that shows us where this mean value would be. And if you notice, so I need a line, a straight line, which connects this point, like the first one, with the last one. Now, since I've just plotted my data, just plot x, it means the indices are from 1 up to, in this case, 10,000, so the length of x. So what I will do, maybe I'll also first redefine this mean value and standard deviation, so that in case I want to use them later in the code, I don't have to type every time 2 and 5, because now I would like to plot here saying that, I also use 10,000 actually as a variable and use n in here. So now I want to connect points 1 and n, so like where my first data point is and where my last data point is, here on the x-axis. And then I know I need a flat line connecting those points, and flat or constant means that for x equal 1, I have value m for the mean value, and then for x equal n, that is also m. And I will say that I want to see it as a red line, for instance. So when I run this, you see now this mean value is right there. Okay, but we wanted to use the histogram. So now let's make another figure. And let's plot histogram of x. So let's see how the default looks. There we are. So once again, now the mean value would be somewhere here, 5. And Matlab has adjusted these bins, so the width of the bins, to the number of data points. It has some kind of formula which it thinks it makes the histogram look nice. We can decide on the number of bins ourselves. For instance, I want much fewer of those, so that now I will have really 10 of those. So the basic histogram, what it does is that it puts the count of points. And so, for instance, I said that I want to see 10 beans. So what happens is that Matlab first checks what's the smallest x I got, and then what's the largest x I got. Then it slices that interval into 10 pieces, and then it checks how many of my data points fell into each of those, and then it plots it as a count. So that's the basic histogram functionality, that it gives you count of points within the specific beans. So when I had, once again, I will remove now number of beans. When we run it, you see now the counts here are lower with respect to what we had a while ago, because now the beans are much more narrow. So of course, those ranges, how much data is in which bin, are much smaller, and naturally the counts are much smaller. All right, so let's go back to help and see what other possibilities there were to actually change things in there. So we had, for instance, the edges. So what that does is that we can decide now. One way was to decide how many bins you would like to have, but you can also predefine what are the locations of the edges of your bins. So for instance, when you have distribution like this and you're not too much interested in those kind of outlier values, then you could predefine, and you would say that if the mean value is 5, so let's say within the distance of 2 on the left and right hand side, you're not really interested much. Let's see, if we say we change property edges, and then you give a vector where you want your edges to be. So now let's look at the graph again. So I would say that I would want this left hand side edge to be, let's say, between 0 and 5 minus 2 is 3, maybe 5 minus 3 is 2, so up to 2, and then from 5 to 8 would be also quite detailed, and then again from 8 to the right it will be roughly all summed up into one bin. So I want my first edge, as I said, to be on 0. Then I want it to be from 2 throughout to 8. I want small bin edges, maybe a bit bigger. And then again, the last bin edge to the right from 8, I would like it to be something bigger, let's say 12. Okay, so let's plot that one. Yeah, probably I used capital letter and it should be small 1. Let's try again. Not. Let's go back to help then and see what was the right way. Oh yeah, bin edges. So that's my mistake. So these were bin edges like that. And we run. So now you can see what has happened. First of all, my bins in between 2 and 8 are relatively narrow, and automatically, of course, the count is quite small. And second thing is that now, since I've combined this left and right hand side to quite a large amount, now Matlab has actually added those up like this. So it looks a bit funny. What I could have done is, if I don't want to see this left and right hand side, I could easily just remove completely those side, so that Matlab will ignore whatever is on the left and right from the edges I have defined. All right, but what I would emphasize most on the histogram, because histogram is such a function that most of you will actually probably end up using at some point, whichever is your area of study, because checking distribution of data is relatively common in any kind of applications. For instance, checking for data normality. This is quite normal when you fit some model and then you have residual. So what's the difference between your model fit and the data? And you would hope that that residual, so the remaining error, is actually normally distributed. So how do we do that check, for instance, for normality based on a histogram? So now we know that this basic histogram function plots our count, but histogram also has the feature of actually plotting for you the estimate of probability density function. So that means that we can actually have that histogram rescaled to such a way that it would represent probability distribution. So that means probability distribution means that the area under our bins should be 1. That's what probability density function actually is. So this one is done in here when you go to normalization property. And then here, so you see count is the default that we have seen. Then there is probability, count density, PDF, cumulative count, and CDF. So the most interesting ones for us are now PDF and CDF. Alternatively probability, but there is a slight difference between probability and PDF. Probability ignores the width of the bins, just because the idea of probability is that when you sum up the heights of your bins, when it's plotted as probability, then they should sum up to 1. But if we try PDF, so probability density function, it means that the area of the bins, so that means height times width of every bin summed up, should add up to 1. So there is a small difference, and usually PDF is your choice when you want to actually look at distribution of your data. So I will make another figure, and I will make histogram once again of X, but now I will say normalization and PDF. So when we run that one, now you can see that the scale here has changed, because it really, when we take every bin individually, take its height, multiply by the width, and sum it all up, we should get 1, or numerically something close to 1. And in this case, it would be nice also to see, it kind of looks like normal, so it has this nice bell shape. It would be nice to verify it against a theoretical PDF curve, and that can be done also. Matlab has a bunch of ready functions where you can draw probability distribution function, probability density functions of various theoretical distributions. Normal, of course, is one of those classic. So I will type in help like this, normal PDF. I already know what the function should be, but we can look in here, normal distribution. This is more of a theoretical explanation. And then we have some functions in here. So for instance, probability density function for one parameter distribution. Yeah, so this looks like what it could be working for us. Let's take that one. So in here you see you can actually draw probability density function, of different distributions once you've given their parameter values. Yeah, so for instance, in here, the way to call it is that you have, use function PDF, then you say normal, so you point out that it's the normal distribution you want to plot, then you give the range of data, so for which points you want it, and then you give the mean value and sigma. So now for my graph, the range of data points, I know that it's actually anywhere between the minimal x and maximal x, because this is how far the histogram goes. So what I will do is here say that maybe I'll call it x1 to be the vector representing our PDF curve. I start from minimal of x, then I take some step size and I go to maximal of x, so that I know my curve will actually cover the whole range of bins. And then my y will then be PDF, the command in Matlab. Then I say that I want it normal. Then I give this x1 as the points for which I want the values. And then I give my mean value and standard deviation, which we had here for our data points. And so once that is there, so now x1 is a vector, y1 is a respective vector that now holds the values for that probability density function, and all I have to do is plot that curve, so x1, y1. Before it comes up, I want it actually plotted together with my histogram, which is in PDF normalization. So I will hold that one. And you see, even though I've done some calculations in between, now when I plot, Matlab still knows that that plot actually goes into that figure. And I will want it as red line, let's say. So let's run it and see what comes out. Yes, so now we have our initial histogram and the red line. Maybe the red line is a little bit thin, so of course we can do some adjustment here, line width, and let's make it 2. So 4 times thicker than original. Yeah, so there it is, and we can also add legend. And so first one was data and the other one was theoretical. And we can add title, data, histogram, for instance. Yeah, so now that's how it looks. You probably noticed that this histogram changes every time I add something and run, but that's natural. Those X values are random, so every time I make a run of the file, it actually brings different results. What could still be done is, for instance, we could make the axis tight, so every time Matlab would nicely fit in the plot just around where the data starts and ends, alternatively. So when it comes to histogram, there is one more probability related function, and that one is cumulative distribution function. So now that one, for distributions, the idea is that now the histogram gets cumulatively added up. So the first bin is what it was. The second bin actually represents the sum of these two, so it would be higher. The third one, the sum of the 3, so it would be much higher. And the last one, sum of the 4, so up. So basically, theoretically, CDF normally looks like that if it's a continuous distribution, or if it's discrete or represented in bins, then it grows. So the thing is that it has the limit at 1. So that kind of, it means that the more bins or the more portion of your distribution you take, the more you're approaching to that theoretical total probability, which is 1. And CDF can also be done in here. So I'll make one more figure, histogram again, and once again I want my data X, and in normalization I choose CDF, so cumulative distribution function. Yeah, so that's how it looks now. And you see it converges to 1. Let's see what else can we comment about histogram itself. There's a number of other features you can change in here, and I recommend that if you're interested, you play with those yourself. You can change the width of the bars. There's something with bin method, different things. You can change edge color and face color of your bins. So if you don't like the default blue with the black edge, you can play with those. These are probably the most important ones. So in relation to this plotting, I would still like to show you now a little bit about the subplots once again. So we had a look at a very basic subplot case where we know, for instance, we make a matrix of subplots 2 by 2, 3 by 3, and so on. But for instance, sometimes you may want to make a graph like that, where, for instance, you have your data the way I have plotted it first, and then here you have smaller subplots that maybe represent the 3 types of histograms I did. So the count, the PDF, so this would be the count, PDF, and CDF, and here would be kind of the timeline plot. So how do we do that one? Well, every time when you use subplot, you have to remember that Matlab thinks of this as a matrix of figures. Now the difference is that now in that matrix a few figures are kind of considered together. So they are combined in some way, and I'll show you how to do that. So in this case I would say that my matrix is 2 by 3, because here I want explicitly to separate those 3 subplots, and this one would be 1 together. So I would go with 2, 3 in here. And how you make it so that that one is combined, that's how we define it actually in this place. And in here it would mean that since we want to cover, if you remember the numbers, which subplot in order we are treating are still the same. So 1, 2, 3, and then there would be 4, 5, and 6 for those. So it just means that to plot it in this way, we would have to put here from 1 to 3, so that Matlab knows this particular subplot is actually covering those 3 elements of our subplot matrix. So let's do it on our graph. So what I will do is I will actually combine now those things I plotted in here. That means that the very first plot, which had the data just as a time plot, is here. And now I will tell Matlab that we create subplot 2 by 3, and we are covering the first 3 of the subplots in here. Then I will remove I'll comment completely. Then here I remove figure, because otherwise Matlab would open actually a whole new figure window. I don't want a whole new figure window. I want a new subplot in a given figure window. So in here, subplot, and once again 2 by 3. But now it's the 4th one. So it's the one going. Oh yeah, sorry. This one was supposed to be there also because that was the count. So actually this was subplot 2 by 3 and 4, and this one is number 5, and then number 6 would be our CDF. Two by 3 and 6. So I make sure I remove figure command from everywhere other than before the very first plot, and my subplot should now be in shape. Yes, and that's how it came out. So you see, once again, also when you have individual subplots, you can still add individually labeling, titles, and legend to each of the graphs wherever you wish it to be, and then those labels will appear respectively around that particular subplot. And finally, one more thing about subplot and, for instance, automating what you plot, or maybe what you put in the titles. So I'll make a small example here now, once again with the 3 histograms I was trying to do. Now I know that I was trying to plot the 3 histograms with 3 different properties, and those properties have names. So I will list them here as cell array. So the first one was actually the default, and that is called count. Second one was PDF, and the third one was CDF. So now you could think that actually this list of properties, or maybe list of variables that you're trying to plot, is longer. So it would be nice to make this automated rather than, so automated meaning you do that plotting and labeling in a loop rather than doing them one by one. So what I will do now is I will make a loop, and it will be from 1 up to length of prop, because these are the 3 different values of my normalization property I want to consider. And then what I will do is that I will design the subplot to be arranged so that the 3 subplots are in this way. So 1, 2, and 3 in here. So I will open now figure command before the plot, the loop, because I only want to open one figure into which I place 3 subplots. If I placed figure command inside my loop, it means that Matlab would actually open new figure window for every subplot, and then we would have those 3 awkwardly looking graphs. So we want one figure, but now the subplots here are being handled within the loop, and I already decided it will be one by, once again, length of prop. So I actually want Matlab to make sure and verify how many I am plotting. And then one at a time we are plotting that if one, so the one which is now being changed by the for loop. And so inside, then I take histogram command. I know I plot histogram of my X data. And then I know that every time I am actually changing normalization, and the normalization I will use is the one which is if on place I in my prop list in here. And same way I can add the title and say here also prop I. So now what happens is that let's look. I starts from 1, so it means it will create subplot, the first one, out of, in this case, 3. It will take histogram, it will make the plot histogram of my X data, and it will consider normalization as the first one in here, which is count. And then it will put also the respective text, this name, in the title of my graph. So you see, instead of having this done 3 times, I have one loop which does it for all. Once again, it looks maybe that the amount of code is not that much smaller in this case, but you might have many more properties or many more variables that you want to plot. And so in this case, you reduce on the coding time. And it also makes your code look much more neat. So now you can see you have your histograms, you can play with the size, and so I have count, PDF, and CDF, and the 3 respective graphs. And Matlab did it for me without me having to copy paste and modify those pieces of code.